All right. Hi, students. Welcome back to the questions about chapter 4.4, part 1. Okay, we will be covering part 1 for this video. Part 1 will cover mostly the basic questions, and don't think they are basic and you feel that they are easy, okay? Because towards the end of the chapter already, they're going to combine everything of what you have learned so far. So it will be like a killer for most of the students if they don't learn the correct way, or if they don't understand things well and let it go. Okay, so when we discuss part 1, right, I'm going to discuss the circle questions. Then the rest you can do it as homework. All right, if you all want the answers, you all can always leave in the comment section below. Then I might give you a sheet of answers. All right, this is for the questions I'm going to discuss. Yep, I'm going to go through question 1 and question 2. 8 questions in total. Okay, so what I'll do is I'll remove this space. Maybe I'll write something. Or maybe I don't have to. Okay, so when I discuss something now, I try to create a space that is next to it, so that I can see it easily. Okay, so for this question, right, I will discuss B first. I will discuss B. So how do you do B? You see. Wait, sorry for the problem. I create another page to solve. Okay, I just solve on top. We solve for B first, all right? So I'll solve it on top. 4 questions. Let me make it systematic. Divide into 4 sections. Okay. Then the first one is, let me do some high-tech flip. Copy. Paste. Okay, this is the question. We will do this question here. Okay, so how do we solve this question? Immediately when I see this question, the first thing that came into my mind is that 2, 4, and 16 are 3 of them are in base 2. They can be expressed in base 2. Okay, because 2 is 2, 4 is 2 squared, and 16 is I made a mistake. 4 is 2 to the power of 2. 16 is 2 to the power of 4. So they can express as 2 to the power of something, therefore they are a base of 2. Okay? They can be expressed as a base of 2. So what we want to do when we solve questions like this, right, is to make everything to be the base of 2 first, since they are able to be expressed in base of 2. So for the left-hand side, what I do is already base of 2. But what can I do is I can actually remove this square root and make it in terms of power. I mentioned many times, if you want to make the square root in terms of power, you just shift it as half, because this is actually your power, this is your root. So actually it's power 1, root 2. Power 1, root 2 is basically meaning your square root. I explained many times already in the previous video. Okay, so 4 is actually 2 to the power of 2 divided by, actually square root 16 is actually just 4. If you know your work, 4. Square root 16 is actually 4, okay? So how do you express 4 in terms of 2 to the power of something? 4 is actually 2 to the power of 2, right? So 4 is actually 2 to the power of 2 in a bracket, x plus 2. I skip a lot of steps, I hope you understand. Okay, so this is for this. Now I see that everything is in base 2. Remember I told you, you want to see 1, 2 on the left and 1, 2 on the right. Only you can combine them. Okay? 1 base 2 on the left and 1 base 2 on the right. But now you are seeing 2 base 2 on the right. So what you do is you combine them first. So on the left, what I do is I can simplify a bit. I can solve this power first. Side by side power, I multiply them. 2x to the power of 2x is equals to this 2 to the power of 2. This is 2 to the power of 2 times 2 to the power of x plus 2 times x plus 2. So what I do is I straight away write the working out, see whether you understand or not. Since it's a division and it's the same base, I can actually minus the power. Okay? But you must treat this as power side by side. First, I multiply them. What I get is 2 to the power of 2x plus 4. I multiply these two powers, okay? So I get this power. And since it's a division, I divide base of 2, which are the same base. What I do is I just minus the power. I'll end up with 2 to the power of 2 minus 2x plus 4. Okay, so at this stage, you only see one base on the left and one base on the right, which are the same. Condition 1 is must be the same base. Yes. Now condition 2 is there must be only one base on the left and one base on the right. So what you do is you by comparing or by comparison, you can say that 2x is equals to 2 minus 2x plus 4. Okay. So you solve for x. What you do is 2x is equals to 2 minus 2x minus 4. Okay. So 2x, I plus 2x here to eliminate the 2x, and I plus 2x on the left hand side. So I'll get 4x is equals to 2 minus 4 gives you minus 2. So x, you bring 4 over for division, or the correct way is I divide 4 for both sides. What I'll get is I get minus 2 over 4, which turned out to be negative 1 over 2 when you simplify it. Divide by 2 up and down. Okay, so you might want to ask me, oh, you told me that base must be the same. So must the power be the same or not? Okay, people might ask questions like this. Some people. So it doesn't matter to ask questions like this as long as it helps you. You must realize that now what we are doing is we are making sure that the base is the same and there's only one on the left and one on the right. Then we compare the top and we solve for x. All right. So of course the top must be the same, but the top is in terms of x. So that is why we are solving for x. You understand what I mean? This is something to say is 2 to the power of 3 is equals to 2 to the power of 3. I know they are the same. I know the top will be the same. The bottom will be the same. But the top has x. It's something in terms of x. Something in terms of x. So I equate them. Since I know that this 3 is definitely equals to this 3. So I equate the top. I find x. Okay? To explain in a very simple term. After B, now we solve for E, okay? Workings that I've repeated before, I won't repeat so much, okay? So that I can solve it faster and save more time for other harder questions. So as when I see this question, right, I immediately can notice that 3, 3, and 81 can be expressed as base 3. Base 3. And these two cannot be expressed in base 3. So we got to think of another method how to find x later. But later we will solve it, okay? Not necessarily you have to change everything to the same base to solve it. Sometimes if you have no choice, but you cannot change to the same base for left hand side and right hand side, you can use log base 10 to solve, okay? I'll show you how. So what you do on the left is that you have 3 to the power of x minus 2 plus 3 to the power of x plus 2, and the bottom is 3 to the power of 4. 81 is actually a base, can be expressed as a base of 3. You must recognize it. Numbers like 3, 9, 27, 81, 243, these are the numbers you want to recognize that you can actually express them as 3 to the power of something. Or in other words, can be expressed as a base of 3. Okay, so what I do is that I try to combine everything on the left hand side. Okay, so you see what you have on the left, you have 3 to the power of x minus 2 plus. What you do now, when you have the same base and you're dividing these two terms, what you do is just minus the power according to law of indices number 2. So you get 3 to the power of x plus 2 minus 4 is equals to 2. Okay? Maybe this question you don't have to use log 10. I'll show you a trick later. Okay, so what you do now is you try to further do it. You try to further solve it first. You get 3 to the power of x minus 2. I simplify this term. What I'll get is I'll get plus 3. X plus 2 minus 4. You just take the number 2 minus 4. What you get is x minus 2. Okay, I made one mistake here, I think. There should be an equal here, and there shouldn't be an equal here. Okay, yep. When you have one equal, you only have one equal, okay? You cannot have more than one equal. You cannot write equal here and equal here. That's not correct. Okay, so now, if you realize, right, these two are exactly identical. So it's something like saying what is 1 apple plus 1 apple? It's 2 apples. What is AB plus AB? If they are completely identical, I can just say it's just 2AB. Because they are completely identical. What is 1 mouse plus 1 mouse? 2 mouse. Right? What is 1 computer plus 1 computer? 2 computers. Okay? So similarly, if I have this one plus this one, what I'll give me is I'll have 2 of this one. I shouldn't write equal again, a bit sleepy already. So I'll get 2 times 3 to the power of x minus 2. Okay, is equals to 2. Okay, now is the thing I want you to pay focus on. This is a step that where people do not know how to solve anymore. Okay, so you must understand, first of all, okay, you can think of it this way first. Since we are learning for the first time, what I'll do is I'll remove these 2 first. Because I can, since they are equal, right, left hand side is equal to right hand side, what I can do is I can divide by 2 on the left hand side and divide by 2 on the right hand side. So when I divide by 2 and divide by 2, what will I have is 3 to the power of x minus 2 equals to 1. Okay, so 3 to the power of x minus 2, 3 to the power of x minus 2 is equals to 1. Okay, you want to express it as base 3, right? Can you express 1 as base 3, you think, Yancy? Because you think, if you can express 1 as base 3, 3 to the power of something, 3 to the power of something, 3 to the power of something, maybe I put a square, you can compare this power and this power, because you have 3 on the left hand side and 3 on the right hand side. So you can compare the power. Okay, so in fact, actually, you have 3 to the power of x minus 2 is, no, what I mean is 1, you can express it as 3 to the power of 0. Because as you have learned, anything to the power of 0 is 1. Okay, except 0 to the power of 0, of course. So I've expressed 3 to the power of x minus 2 is equals to 3 to the power of 0. So I can conclude by comparing, I have x minus 2 is equals to 0. X is equals to, I plus 2 on the left, plus 2 on the right. X equals to 2. I get it. Okay, there's another method to do it. Okay, there's another method to do it by using your knowledge on indices. Still arrive to this step is equals to 1. What I do now is you think to yourself, 3 to the power of what will give you 1? So you must know, anything I don't care, as long as it is not 0, what do you power it with to get 1? Okay, to power something to get 1, you must know that this one must be 0. Okay, this is like this kind of second method that you learn from your knowledge on logarithm. Anything to the power of 0 will give you 1. Therefore, I can straight away say x minus 2 is equals to 0. X is equals to 2. Okay, this is E, okay? It's not very hard, okay? These are still quite simple questions. We move on to F. All right, we move on to F, yeah? Okay, see, when I first spot this question, I can immediately tell, right, they can express to be in the same base. They can either be expressed in base 2 or excuse me, base 4. All right, so I try to do both lah. See, you can get it or not, because not necessarily you have to express it into the smallest base one. As long as you can express it to the same base, right, you can actually solve the equation already. The purpose is to express them into the same base, not necessarily the smallest base, but usually you express it to the smallest base lah, unless you see questions like this where you can express 64 in base 4 also. So I can actually express in base 2 or base 4. I'll solve for base 4 on the left, okay? Okay, so how? So you know that if you want to solve into base 4, this is already in base 4. So I have 4 to the power of 3x plus 2 is equals to, okay, how do I change 64 to the power of 64 to base 4? You must know that 64 is actually 4 to the power of something, and that something is actually 3, because 4 to the power of 3 is 64. Okay? Yeah. So basically it means that 4 times 4 times 4 gives you 64. But don't forget, you still have a power outside of x minus 10. And you have a square root. Okay, I tried to do it in one step so you understand now. This square root, I convert it into power form. So I said many times today, if you convert into power, don't forget to put a power of half. All right, so don't be scared of so many brackets. As long as the powers are neighbors, you can multiply them. You understand me? As long as they are neighbors, you can multiply them. So you have on the left 4 to the power of 3x plus 2 is equals to 4 to the power of, you multiply 3 of them. What do you get? 3 times 1 over 2 gives me 3 over 2. 3 over 2 times this in a bracket gives me 3 over 2x minus 3 over 2 times 10 gives me 15. Okay, how I get this one is just basically multiplying these 3 things. I hope you get it. Is it correct? 3 over 2x minus 3 over 2, 5. Yeah, correct. So now you realize that these 2 bases are the same. then therefore you can say that the top must also be the same. So you can straight away write 3x plus 2 by comparison or by comparing. You know that 3x plus, don't put equals, okay? Because you're going to have an equal on the right hand side already. 3x plus 2 is equals to 3 over 2x minus 15. Okay? So you just solve your normal maths. You minus 3 over 2 on, you want to bring this one over. I will just use bring over because it's easier to use. 3 over 2x bring over to the left hand side gives you 3 minus 1.5 is 3 over 2x. And then I bring the number to the right hand side. 2 I bring to the right hand side gives you minus 17 equals to negative 17. So x, you can solve it. You bring what you do. How do you solve for x? Basically, you times 2 over 3 and you times 2 over 3. Why I times 2 over 3? Because when I times 2 over 3, I can eliminate this fraction beside the x. So I can isolate the x. Okay? So I'm left with minus 17 times 2 over 3 gives me negative 34 over 3. Okay, since I'm teaching like one go, and I'm not checking the answer, so I might make a silly mistake. All right. So if you spot any silly mistake, do notify me in the comment section below. Okay, but never mind. Since I'm solving for base 2, I can actually check my answers. Okay, so now I'm going to solve for base 2. Same thing. Okay, I try to solve faster a bit. So actually 4 is actually 2 to the power of 2. 3x plus 2 is equals to 64 is actually 2 to the power of 6. Then you have x minus 10. Then you have the square root. The big square root, as I said, I'm going to convert it into a power, half. 3 neighbors, you can straight away multiply them. So you have this one on left is 2 to the power of neighbors. Again, powers, when powers are neighbors, you can multiply them. 6x plus 4 is equals to 2 to the power of, you multiply them, half times 6 gives you 3. 3 you times inside gives you 3x minus 30. Okay, so by comparing, I won't write full sentence because I want to do it quickly so I can move on to the more questions to do with you. You write 6x plus 4 is equals to 3x minus 30. So I get 3x is equals to minus 34. X is equals to minus 34 over 3. Yep, I got the same answer on the left and on the right. So it's actually correct. No silly mistakes. All right, so we solve for G, okay? Question G, what you do is that you realize that this 4 can be converted into base 2, right? So you do that first. 2 to the power of x minus 1 times 5 to the power of x is equals to 2 to the power of 2. Okay? Then you try to group the 2's together first. You try to group the 2 together. Maybe you can bring this 2 to the power of x minus 1 over there for division because this times, okay? So you bring over there for division, what you get is you're left with 5x here, and then you're left with 2 to the power of 2 divided by 2 to the power of x minus 1. Okay. So now what you get is 5 to the power of x is equals to same base, you can minus the power. 2 to the power of 2 minus x minus 1. So what I'll get is that, I'll get 5 to the power of x is equals to 2 to the power of minus x plus 3. Okay, I'm here at this step. All right. So since now you have no idea on what to continue from here, usually you don't have anything else to do already. What you use is your final weapon, which is log base 10. Why do you use log base 10? Because log base 10 can always generate you the answer in your calculator when you reach the appropriate step. So what you do is you log base 10 both sides. Log base 10 5x is equals to log base 10 2 minus x plus 3. Okay? Maybe somehow you're able to solve it later, okay? So now we move on. We do what we can, okay? Log 10 5x. 5, the x I bring forward to become x times log base 10 5 is equals to, bring this power down. Similarly, according to law of logarithm, I'll get minus x plus 3 log base 10 2. Okay, I try to group the x together first. Okay, because as I told you many times, when an x is in front, you can just treat it as normal multiplication. Okay, this is like normal multiplication. So if you want to expand this one, can. You want to expand this thing? Can. Watch out, I want to tell you something first. This one you can expand it into negative x log base 10 2 plus 3 log base 10 2. But, I say but, if you see something like log base 10 2, log base 10 x plus 3, this one you cannot expand it into log base 10x plus log base 10 3. Take note, I repeat many times already. I think I repeated in 4.1. You cannot do this, all right? Because this is part of the log. This on the right side is part of the log, all right? The one on the left is not part of the log. The one on the left is something like another thing, multiplying the log. Okay, but this number behind this log is actually part of the log. It's like one family. It's like alphabet A or alphabet B. It's like one thing. Okay, so as I said, you can actually expand it. So on the left, you have x log 10 5 is equals to this after expanding. So I group the x together. So what I have is I bring this one over for plus. So x log 10 5 plus x log 10 2 is equals to, left with this one, 3 log 10 2. Okay, then you realize you can factorize the x. Why I can factorize the x? Because I said it's normal multiplication. Okay, or you can think of it as 2x plus 3x gives you what? You plus the 2 and 3, right? 5x, right? So you plus these two things in a bracket x, or somehow you factorize the x out. You're left with log 10 5 plus log 10 2 on the left hand side equals to 3 log 10 2. Okay, this is a very good question. Okay, because if you're not used to the type of question, right, you will only realize the trick until you reach this step. Because why? Because why? I said because why. I label here is a trick question, good question. Because why? I know that log 10 5 plus log 10 2, log 10 5 plus log 10 2 will give me x to the x to what? Log 10 5 plus log 10 2 will give me, when you have two logs of the same base and you plus, by law of logarithm, refer back to your law of logarithm notes, you can actually times the content of this thing on the right. So what you do is you have log base 10 to 5 times 2 is equals to 3 log base 10 2. So this is x log base 10 10 equals to 3 log base 10 2. Okay, so this is a very special thing. You can know that log base 10 10 is actually equals to 1. So we can therefore say that this is left with x only, because x times 1 is x. Okay, so x is equals to 3 log 10 2. So out of a surprise, you actually got the answer already. Okay, this answer you don't have to calculate. You can leave it in this form, depending on the question. If the question expects you to calculate in decimal, then you leave it in decimal. So G is a very good question, okay? That's why I said, try to do as many questions as possible. So far, all the questions I did, G is the important one. The one that you will tend to not know how to do. You get what I mean? But as I said, when you do not know what to do, right, try your best to use tricks or use what you can do at that moment to help you out. That is the goal of it. Okay, so I'll try to solve question 2 also. Question 2, as usual, I'll solve a few questions. I'll solve 4 questions. I'll solve in this cross. Okay. So I will take, since these 4 are together, I can bring this. Let's not do it. Let's take one by one. Copy. Paste. Copy 2 questions. Okay, so I will discuss these 2 questions first. Okay, so just now for number 1, right, we solved normally is it was on numbers only, okay? It was on numbers, basically indices. Now we solve log. Okay, but they are the same thing. I mean, not to say they are the same thing, but I just classify them this way. so that you can know what questions to attack for, to look for when you're doing the question. So for question B, you have the question here already. So what you do is, okay, you notice they're already in base 2. Log is already in base 2. So what you want to do is you want to make sure there's only one log on the left and one log on the right. Okay? Yes, there's one log on the left, correct. There's one log on the left and there's one log on the right. But are they exactly the same? Not yet. Why not yet? Because there's a negative here. So what you do is you bring the negative up, power of -1. So what you do is you have log base 2, 2x, bracket -1. Watch, this is another trick that you don't want to forget. I don't straight away write -1, okay? I don't straight away write -1. Because if I write like this -1 will belong to x. What I do is I put a bracket here. Excuse me. So I put a bracket here. Then I put the power of -1 up there. Okay? Because -1 belongs to the whole 2x, does not belong to x only. It belongs to this whole thing. Okay? So plus 3. Okay, this 3 is going to cause a problem later. So equals to log base 2, 3x minus 1. This thing you cannot do anything about it. Just leave it. So on the left, you see you have log base 2 and log base 2. But you're not ready to compare yet because there's this 3 here disturbing you. Correct or not? This 3 here is going to cause trouble. Because you want to leave it into log base 2, you have only log base 2 on the left, one log base 2 on the left, and it must be the only thing on the left. Log base 2 something is equal to log base 2 something, only you can compare. You don't want to have plus 3. You understand? So try to remove the plus 3. How do you remove the plus 3 is also another trick. You can express any number in terms of log base something. How? If I want to express 3 into log base 2, what can I do? I can do, think and see what can you do. Okay, I give you a few seconds to think. It's actually quite good thinking of this thing. How can I express 3 into log base 2 of something? Okay, so the answer is actually this. I can actually, because you notice that you will know that 3 is actually 3 times 1. 3 is actually 3 times 1. Correct? So 3 times 1 is actually 3 to the power of what gives you 1 in base 2. Don't you think it's log base 2, 2? It is. So log base 2, 2 will give you 1. So I just express it this way. So I can actually express it in this 3 I bring up for power, becoming the power. It becomes log base 2, 2 to the power of 3. So I give you log base 2, 8. So actually log base 2, 8 is actually 3. Okay, as I taught you how to interpret log, is you look at this base to the power of what gives you 8, which is also 3. Okay, not hard. So you use the trick when you have a number 4. Just put log base 2 to power 4. Okay, or if you want to express number 10, you just put, I want to express in log or in base A. Okay, what I do is I just put log base A, because I know when log base A appears, it will become 1, so I don't care about it. Then power of 10 up there. Okay, but before power of 10, of course, the 10 exists in front first, because 10 times 1 gives you 10. Okay, 10 times 1 gives you 10. So when you bring this 10 up there for power, you take log base A to the power of 10. This is what you do, okay? So this is another trick I want you to write down. So I can express log base 2, this is 2x minus 1, okay? 2x minus 1 in the bracket, 2x in the bracket minus 1 to the power of minus 1, plus this 3 is actually 3 log base 2, 2. I write down the working here, okay? I'll rub this off first. So it's equals to log base 2, 3x minus 1. Okay, now you have 2 log base 2. So what you do is you want to combine them. But if I told you the rule to combine is actually you have to bring this power on top first. Okay? When you want to combine, you tend to work in the opposite direction of the law of logarithm. For example, law of logarithm tell you that if you have log AXN, you can actually write it as n log base A x. You can bring the n down. Okay? So actually there's some observation I've made because I've done enough questions. When you want to break things down, when you need to break things down for substitution questions, you normally go in favor of the rule. But whenever you want to combine things, you tend to work in the opposite direction. This is like one general rule you can try to remember yourself lah. I do not know whether it works every time or not, but you can remember yourself. Okay? So what you do now is you want to combine things. You want to combine these two. So you want to actually go the reverse of the law of logarithm. So you bring the 3 to the top. Okay? So what you achieve is you achieve log base 2, 2x to the power of -1 plus log base 2 to the power of 3 log base 2, 3x minus 1. So what you do is you can combine these two log. How do you combine? Is it like this? 2x minus 1 plus 2 power 3 is wrong, huh? You are not factorizing, okay? You are combining them. Okay, again, you are moving in reverse of the law of logarithm. Law of logarithm told you have log A BC is equals to log base A B plus log base AC. Okay, but now we want to combine it. When we want to combine, we are moving opposite direction. So make sure you know how to move in both directions, not only in one direction. That is very important, that I'm trying to emphasize. A lot of people know this direction, but they do not know how to work backwards. Not to say they do not know, is that they do not realize they need to do it at certain instances. Understood? So when you want to combine, you work backwards. So you try to combine them. So when I combine, don't forget, when you have log base 2, you combine them, and it's a plus in between, you try to multiply them. 2x power of -1 times 2 to the power of 3, okay, in a big bracket, equals to log base 2, 3x minus 1. Okay, now you have one log base 2 on the left, one base 2 on the right, and you don't have other things. Okay, you don't have other things on the left and right. So now you can neatly compare. By comparison, left will be 2x to the power of -1 times 2 to the power of 3 equals to 3x minus 1. You compare, okay? Okay, so now what you can do, you try to break everything up first. You try to break everything up. Okay, you try to expand everything. Then you try to solve. Expand this one. When remember we learned in law of indices, when you have a to the power of b, ab to the power of n, it's actually an bn. Okay, so I know that if I want to expand this bracket, what I do is the power I times inside, the power I times inside. Okay, this is also something you can do. 2 to the power of -1 times x to the power of -1 times 2 to the power of 3 equals to 3x minus 1. Okay, same base, I can combine them because it's multiplication. Dot is multiplication. So what I do is I combine them. When I combine two same bases that is separated by multiplication, I can add their powers up, because a power n times a power m equals to a power n plus m by this theorem. So -1 plus 3 times 1 over times x to the power of -1 is 1 over x. How do I know? I told you before, this negative change it to 1 over. And then what do I write down there? Is basically x to the power of 1. Don't repeat the negative here, because the negative has already become transformed into 1 over. So don't write the negative down here, okay? Don't make a mistake by writing negative down there. So once I transform this, so right hand side will give me 3x minus 1. Okay. So what I do is I try to shift x to one direction. I try to shift x to the right hand side. So after rearranging, you have this one 2 to the power of -1 plus 3 is 2 to the power of 2, because this one gives you 2. 2 to the power of 2 is 4. 4 is equals to, okay, then I shift this x to the right to become multiplication. Why I can shift it to become multiplication? Because it's I basically times x to the left hand side and I times x to the right hand side. Okay, when I times x on the left hand side, right? Since this is multiplication, right? So you can cancel it once enough already. You don't have to cancel with this and cancel with this. You cancel it once. Cancel, cancel, done. Sorry. Okay, because everything is multiplying. You understand? Everything is multiplying each other. Unless if this is a plus, then you have to multiply one by one. But if it is times, you cut once is enough. You understand? So what I get is actually I get 4 is equals to, on the right hand side, when you multiply, you get 3x squared minus 1. You see this is minus or plus, this minus, right? So you've got to times 1 by 1. Okay, so now you have left yourself with a quadratic minus x not minus 1 with a quadratic equation. So what you write is 3x squared. When you solve quadratic equation, don't forget the general rule is to express it in general form. Minus x minus 4 is equals to 0. Press your calculator, get your both answers. Okay, get your both answers. Wait, I get your both answers. So actually, I think I can solve this. Let me think how to solve this. 3, 1, 3, 1, 4, 1, 3, 1, 4, 1 minus 4. So it's 3x minus 4, x plus 1 equals to 0. If you do not to solve this one, doesn't matter. This I use it by mental factorization. But if you do not know what to do, type in your calculator to solve this quadratic equation to get both answers first. You understand? Once you have gotten both answers, you work backwards. Okay, further details on how to do it, I'll explain in quadratic chapters. Once I reach there, okay? Minus 4 plus 3 minus 4, correct? Yeah. Further details on the exact steps on how to do this and not get any marks lost, I will discuss it in, what do you call it? In that particular chapter itself. Right, so I will try to save some space. I'll throw this to the right hand side. Okay, as you can see here. No, right hand side also has something on it. So I'll throw it maybe somewhere here. Or maybe I can put down here, it doesn't matter. Okay, this is still part of this. Okay, so for question C. Question C. Okay, I know it has the same base already. I can see they have the same base. So I try to express this one into the same base. Okay, I try if I can do it. Okay, I told you a number, you can express it into a log base something very easily. Because 8 is basically just log base something, something. This would become 1. Then you times an 8. Because 8 times 1 will give you 8. So I want to express in terms of log, I can just make any base I want. I can just make, if I want a base A, I just put A here. If I want base B, I just put a B here. For this case, I want base of square root x, I put square root x here, I put square root x here. Then I got it. Okay, it's very easy. So 8 will become 8 times log base square root x square root x. Ask me, if you want to ask me again how I got this one, it's because this one will give you 1. Okay, so I don't write this later, you get confused. Okay, so what you do is, and these two, don't forget the general rule for solving and comparing, right? If you want to compare, like if you want to compare log, is to actually combine everything. If you want to solve, you combine everything. You try to combine everything when you want to solve for x. So when you're solving on the left hand side, you try to combine them, and combining is most likely you use the reverse process of laws of logarithms and law of indices. So you tell yourself, how do I combine these two? When they have the same base, log of the same base, I combine them by multiplying them into log of the same base. So 125 times 5. It's not plus 5. Always refer back to your theorem. Log ABC equals to log AB plus log AC. So now I'm actually moving in the opposite direction. So in other words, log AB plus log AC gives you log AB times C. This is a times. That is why this is a times. You see? Okay, I'll write this off. Not related. Okay, so I have combined on the left, so I continue to solve. So I try to solve this one. What is 125 times 5? I leave it as 125 times 5 because I'm lazy to calculate now. Okay, so so you realize that you need to shift this one on top. Why? Because you want to make it a clean log base square root x. Because on the left is a clean log base square root x. So you want to bring the 8 upwards. Okay, let me tell you something about comparing. If you want to compare something, right, you must make sure the looks of the left hand side is same as the looks of the right hand side. Means if there's no 8 here, you don't want the 8 to be here. You understand? You want them to look exactly the same, then only you compare. That is the idea of why I'm removing this 8. So I bring this log base square root x of square root x up here. This 8, okay, up there. So what I do now, okay, now it's exactly the same already. Now it's exactly the same already. log base square root x, log base square root x, then something on the right. So since it's exactly the same, what you do is by comparison. 125 times 5 is equals to square root of x times to the power of 8. So when you solve things like this, you don't know what to do. Change the square root to power. It's x to the power of half to the power of 8. Neighbor's power will give you multiply the power, give 4. So you have this one, 625, is it? Yeah, 625 will be equals to x to the power of 4. Then you solve for this question. X is just the fourth root of 625, which I think will give you 5. You type in your calculator. Okay, any question you all want to ask me on how to type calculator, you all leave me a comment section below, and I'll try to make a video on it. That is question C. Okay, question D and E are different kind of questions. So I'll put a type of question, type here. It's different types, so I'll put a word type there. Okay, so I would say question C is actually quite a common question in exam. It's quite a common question in exam. Question B is also quite a common question in exam. Both of these questions are not counted as easy already. They are quite difficult already. Okay, but question D and E, they seldom ask, but you still need to know how to solve them. Okay, I'll just bring them together. All right, so we move on to question D now, all right? So how would you solve question D? If you were to study my lecture notes, right, you would realize that actually when you have 3 log 3, it is actually the anti-log method. You can use the anti-log method to solve, and it will leave you with the answer x plus 1 is equals to 5. Only when this number and this number is the same, then you can do it. Okay, and this log is actually the power on top, only you can do it. But if you don't remember, just say if you don't remember to solve, to do this, you can think of it as this is actually 3 to the power of something equals to 5, right? So actually what you can do, right, you can try to do things. Can you use any law of logarithm? You cannot use anything. You cannot do anything with this. Can you use any law of indices? There is no same base. You cannot do anything. So you try to think of other things that you can use. Oh, I realize that this is actually an index form. So you try to convert it to log form, logarithmic form. This is the first thing we ever learned, okay? In logarithm, in 4.3. So what you do is, what I want you to do is, you try to convert it. Try yourself. Try to convert this index form to logarithmic form. What will you get? Okay. How do you convert is when you have a to the power of x equals to b. Remember I told you log base a, b equals to x. The power will become the answer. All right. So the base is 3. The base is 3. What I'll get is I'll get log base 3, and the power would become the answer, x plus 1. And then the last alphabet, no, not x plus 1. The whole thing is the power. If you realize the whole thing is the power, I missed out. The whole thing is the power because you are treating this whole thing as a power now. Think it as one thing. So log 3 x plus 1. This is like the power, okay? This is like the power. And what is left is the last number, 5. If you realize. Okay? So if you reach this step, right, you realize that you have log base 3 on the left, log base 3 on the right. Therefore, you can compare straight away. 5 is equals to x plus 1. X is equals to 4, which is the same answer you will get here. Okay? So if you remember the method to do it, use the anti-log method, you can straight away get 5. If not, right, when you see questions like this, right, try to see whether you can convert it to logarithmic form and solve it or not. So this is a type of question you need to note down. Okay? Let's move to E. E is about what? Oh, E is another tricky question. It looks simple, but if you do not know what to do, then you will just log base 11, is it? Log base what? Log base x minus 1. Log base x minus 1, 11 is equals to 11. A bit tired today. Okay, so what do you do with this, right? If you do not know what to do, can you change any base? Cannot, because 7 and 11 has no related bases. Okay, and then can I simplify anything about this log? Cannot. So you know you won't use law of logarithm or law of indices. So you try to think back to original. What can you do about this? This is actually an index form. So if I convert it to log form, what will I get? So it's actually something to the power of something equals to this. You try to think of it as a to the power of x equals to b. You know that log a, b is equals to x. X is always the answer. Okay, so what I do here is that I will straight away change it to log base 7. This is the base because this is the one with the power. Log base 7, 11 gives you the power. The power is the whole thing, okay, because it exists on top of the 7. So you get log base x minus 1, 11. Okay, here comes a part where you can compare again. But I don't think I included this in my lecture notes. But I want you to know when you have, for example, when you have 11 on the right, 11 on the left, 11 on the left, 11 on the right, and they have different bases, you can also compare. By comparison, you get x minus 1 is equals to 7. Okay? As long as, okay, for now, I want to see, ask yourself, you want to compare this one and this one, right? You want to ask yourself whether you can compare, right? You think and see, other than this highlighted, this yellow highlighted portion, right? Are the rest exactly the same or not? You check. Okay, on the left, you have 1 log, on the right, you have 1 log. Correct. And you have 11 here, and you have 11 here. Oh, correct. So other than the highlighted part, everything else must be everything else is the same. So you can compare. 7 is equals to x minus 1. X is equals to 8. Okay, this is the way you can check if you can compare or not. Don't forget, this is a very important thing to check whether you can compare. All right, so actually we have gone through quite a number of quite tough questions. Quite tough, even though it's in part 1, but they are quite tough already. That's why I said never underestimate questions in part 1, even though they're in part 1. Okay, there are many different types that I've gone through. I hope you learned something, and I hope that you have written down all the solutions by yourself and really understand them. You can try other questions yourself, all right? You can try other questions. And you have any questions that you're not sure of, like a particular H you do not know how to do, or you have done, you need to know whether you're right or not. You just ask me in the comment section below, and I will go through with you. All right, so that is all for part 1. Okay, that's all for part 1 for chapter 4.4 on questions. Okay, I might be a bit blurred today, like make a bit of minor errors when speaking, because I'm actually quite a bit exhausted a bit already, because it's approaching the night already. All right, so forgive me. I think you can understand lah. Other than that, if you have any questions, as I repeat again, leave in the comment section below, and I'll end the video for this particular part 1 question. All right, see you in the next video in part 2.